Hello. Hey guys, how are you doing? Let's see, where is everyone joining from? So we are joining from Spain, India, Switzerland, USA, Pakistan, Barcelona. Awesome. We are joining from everywhere. Switzerland. Hello, everyone. Let's just wait a couple of more minutes for the rest of the guys to tune in, and we'll be starting in no time, okay? I hope you can hear the voice correctly. Let me know if it's too low or too high. I'll just change the settings. Also, I'm a bit, I have a bit of a cold, so I might have to take some breaks in between. I hope all of you are doing well. Okay, all good. Perfect. So let's just make sure everything is there. Doing great. Awesome. Thanks, Andrea. Yes, I'm feeling a bit cold, but let's see. Great. Let's get started, I think. All right. So first of all, thank you very much, guys, for joining us on a Sunday evening or morning if you're from the US. Let's create some CAD model of a VR headset. Apart from that, we hope all of you are safe and sound and doing great in your design endeavors. Make sure to download the resource files so you can check the description. You might find a link and you can download the exercise files once you register. You will find it in the after you submit the form. There is a download link. You can download it from there. Okay. And also turn on your Rhino and Grasshopper environment. I know some of you use a lot of plugin and it might take a long time for you to turn that on. So I have already turned on my Grasshopper environment before because it takes like 2-3 minutes just to load the plugins. I'm Aman Agrawal. I'm an industrial designer based in Madrid. I'm from India, but been living here for almost 7 years. And I also give online classes at Academy. And at Academy, we provide live training to students, designers, and design studios. Okay, we will talk about it later on. Great. So what are we gonna do in this workshop or in this webinar? We will start by creating a VR headset in Rhino environment. And on certain surface part of the VR headset, we will apply texture using Grasshopper. And once we have done that, we will move to Keyshot and we will render the VR headset. Okay, so let's get started. Okay, so we will model CAD model in Rhino, apply texture in VR in Grasshopper, and render in Keyshot. Perfect. So let's turn on the Rhino environment. Any question meanwhile, all of you, were you able to download the file? Pelin asks if the stream will be available once we end it. Yes, we will send an email to all the registered users, the link to the webinar as well as the download link. Okay, just let me make sure if I have Okay, meanwhile you can download the resource files. Okay, perfect. Great, so let me turn on the Rhino environment. All right, there we go. And in the download folder, you will find 3 different files. Okay, the first one number one is the Rhino file. So we will start from there. Then we will move to the Grasshopper file and then the rendering files. So some of you are asking, no, you haven't missed anything. We are barely starting. Where can I find the files? In the description, you will find the link. But if you're not sure, you can always go to www.academy webinar 3 and you can download the files after the registration. Okay, I'll just leave the link in the chat. There you go. All right, so let's get back to the Rhino environment. Okay, so let's open the first Rhino file. Okay, so let's just drag and drop, or you can go files and open. Let's open it. Okay, so as this modeling of VR headset consists of a lot of steps, I have broken it down into like step-by-step process so that you can have a look at it. Okay, so we will try to model to a certain extent the VR headset, and I'll also explain what we are doing in each step. Okay, so if you want, you can even hide the workflow layer, but if you want to have a look at what we have done till the end, so it's a really long process, as you can see, but we will take it slow, don't worry. Let's go to the front view. Okay, so how shall we start modeling it? So you will see that I have added a couple of construction lines here. Okay, so the blue rectangle is the general dimension of the VR headset, and the red curve that you see is basically the outline of the front part of the VR headset. So we need to create this red line. How would we create that? There are a couple of ways of doing it. So the easiest way is, first, from your rectangle geometry, you create a line like this, okay, this black line, and you create another line starting from here. Okay, if you want, you can hide these two reference lines now, and we need to join these two curves in such a way that we are almost following the red curve, our reference curve. Okay, so which command can we use for this one? I mean, I would ask you, but okay, I have someone in the chat who already suggested we can use BlendCrv, and exactly that is what we are going to use, BlendCrv. Okay, so you can write the command in the command bar. Also, for those of you who are barely starting with Rhino, I highly recommend you to turn on the help menu, okay, here, and make sure to turn on the auto update option. So when you do that, every time you run any command, this part will automatically update and it will tell you how to use that command. Okay, so in this case, let's rerun the BlendCrv command, and we will select this curve, okay, and the starting of this curve. And you will see we get this adjust BlendCrv handle. And there are different ways we can define the continuity of the curve with curve number 1 and with curve number 2. So you can make, let's say, positional from curve number 1 and curve number 2. That means these two endpoints are in the same position. When you set it tangency, it's also called G1 continuity, you're positional continuous, and it's also tangentially continuous to the other curves. And we can do that for curvature and G3 and higher. Okay, depending upon what is your design intent, you can choose any of these. So let's say we choose the curvature continuity, okay, and you can click on these handles and you can change the dimension as you wish. Okay, you can see I'm just moving these handles to approximate the red curve. So once you're happy with the dimension, let's press OK, and there we go. This is our 1/4 of the curve that we will need to create the entire front part of the VR headset. So the next step is going to be basically creating a copy or mirror of this curve on the other plane. So I'll use the mirror command. We will start from here and just create a mirror with the shift key on the other plane. Okay, and we will repeat the same step for the bottom half. And there we go, we have created the front part of the VR headset. Of course, we have just created the curve, we haven't created any surface yet. So that is what we will do in the next step. So if you want, you can continue from the perspective view. Okay, let me just unblock the layer. Okay, let me just give you some time so that you can catch up till this part. Any questions so far? Just let me know in the chat. Okay. So this is how I created the first curve, and we created the mirror and reflected the mirror curve. So we have a planar curve, as you can see. So how can I generate a surface from a planar curve? Anyone in the chat? Yeah, there is a lag, so I might have to tell it earlier. So when you have a closed curve, and that is planar, that means all the control points are in the same plane, you can create a surface by using a command called surface from planar curve. Okay, so let's select the curve, and there you can see now we have a surface of that dimension. Couple of things to keep in mind, a bit more technical term. This is a trimmed surface, okay, which means that it was originally a rectangular surface and we cut out this shape from the rectangular surface. At the moment it's not really important, but when we go to Grasshopper trimmed surface, we have to deal them in certain way. Okay, great. Once you have the surface, I'm just going to move everything, let's say -200 units with the gumball. You can click the gumball and you can input the value. And the next step, let me just copy and paste it, 200 units. So the next step consists of rebuilding the surface. So if you turn on the control points of this surface, you will see that it just has 4 control points. Okay, we want to deform this surface for the front part of the VR headset. So we are going to rebuild it. Okay, rebuild, and we will set degree 6 curvature in U and in V, and 7 control points. Okay, so it will be set automatically. You just have to write 6 by 6 here. So we are basically adding a lot of control points in vertical and horizontal direction so that we can stretch these points and manipulate the surface. Okay, some advanced concepts here. So we are creating a single span U and V surface, okay, because we are defining the exact number of degree plus 1 number of control points. This has its own advantage when you're doing advanced surface operation. All right, and now you can see we have a lot of control points, correct? Now we just need to select these control points and we can move them in order to deform the surface. So what I have done here is I have given some instruction on how you can deform it. Okay, so let me just create a copy, paste it by 200 units, turn on the control points, and let's go to the top view. Okay, so you can see the first set of control points, I have moved it by 5 units. So we can move everything by -5 units. Okay, the next set of points we have moved by 9 units, so it's going to be 4 more units. Okay, so select these 3 and move it -4. And the last set of points we have moved it by 12 units, so 5 plus 4, 9, plus 3, 12. So this last set of points, we just move it by 3 units. Okay, and that is how we have created the front part curved for the VR headset. Okay, any questions so far? Just write it down in the chat and I will try to answer it as we proceed through the exercise. All right, so what is going to be the next step? So the next step is going to be converting this surface into a solid geometry. Okay, that way we can give it volume. So I'm just going to copy and paste it, move it to 100 units, and you will see you can extrude this surface. So I don't know if you have used the gumball a lot. In Rhino, you can of course move the geometries, you can rotate the geometry, you can scale it in X, Y, and Z axis. But if you pay attention to the gumball, you will also see that on the 3 axis, you will see these circular dots of red, blue, and green color. So what you can do actually is whenever you see these circular dots, you can click and stretch, and that is gonna extrude the geometry. In this case, a surface into a poly surface. If you do this to a curve, it's gonna extrude it into surfaces. Okay, in that way you can extrude the geometry. And you can see we have a closed poly surface. Okay, great. So the next part is about adding some fillets. Okay, so you can of course go to solid, fillet, and add a fillet to the edge. So I'm not sure what was the fillet amount, but let's say it's 20. If you double click, it's gonna select the entire tangent edges and you get something like that. Okay, the only thing is when you go to the render viewport, you might see the quality of fillet. You will be able to see where the different patches of surface are meeting each other. Okay, so this is a problem of continuity, and you can also judge the surface quality by running a command called environment map, EMAP. Okay, or you can also go to analyze, surface, environment map, select the geometry, press OK, and you will see that it pops up this tool. You can change the type of HDRI, and here you can see how your surface looks when it is applied a reflective environment all around it. So you can see there is a visible transition between this patch of surfaces and this patch of surface and then this patch of surface. So what I can recommend is you can actually duplicate the edge, dupe edge, okay, of this, and this edge of the surface. So you will end up with this curve, right? Make sure to join it back as well. So you can join it by the join command. And what we will do is we will convert this curve into a pipe. So run the pipe command. I think the diameter or the radius is 15 units, or maybe 10 units, I think. 10 units, yeah. And you will end up with a tube that is going around the edge of the front face. Okay. And it's made out of single surface. So what we can also do is we can actually simplify this complex surface, right? Can you see this is really complex? Always you should strive to represent the geometry by the simplest shapes possible. Okay, so we can rebuild this surface by 8 control points in this direction, and I think anything that has to do the multiple of 8 would work. So 16, 32, any of the values multiple of 8 will work, right? And here you can see we have a really simple clean surface if you compare this with the other surface, right? And we will use this surface to basically trim or split our poly surface into something like this. Okay. Any advantage of EMAP versus Zebra? Well, yeah, EMAP generally will reflect, let's say if you are creating some polished or glossy render or geometry, then you can judge it better using EMAP, like the overall fill. Zebra will help you understand how the ISO curves are flowing along the surface. Even though your surface might look great under EMAP, under Zebra it might look different if the ISO curves are distorted or they are, you know, skewed in certain direction. So Zebra is more used when you're trying to match surfaces or do some advanced surface operation. EMAP is generally used to get a general look and feel of the geometry. Okay. And once we have the trimmed geometry, we can connect these two shapes. So does anyone know how can we connect it? What are the different tools that we can use to connect it? So you have BlendSrf. Yes, a lot of you use BlendSrf, so that's what we are going to use in this case. BlendSrf. So you can select the edge, and it's asking us to select the second edge. Okay. The thing is, our first edge is split into multiple segments, like 4 segments. So what we can do is this. Let's blend the surface and we will chain the edges. Okay, so let's connect here.
Sorry, I don't understand.
Yeah, my Google Home is freaking out. Sorry, guys. Okay, so let me repeat. Blend the surface, chain the edges. Okay, then we will select the other edge, and it's gonna draw this seam line. So you can position it here or you can position it here. Press OK, and like BlendCrv, you will get this blend surface tool where you can control what kind of continuity you want between these different patches of surfaces. So in this case, you can leave it at curvature, which is more than enough for a geometry like this. But if you want, you can go higher with this. So once you have defined the curvature continuity parameter, let's press OK. And there we have the final output. Okay. You might wonder, some of you, that why I have certain faces looking purple and certain faces looking white. Well, in NURBS or even in mesh, your face has a positive and negative side, and in general Rhino doesn't show you the positive and negative side in 2 different colors, but you can change these settings if you go to document properties. Let's see if it opens. Okay, we go to view, display mode, shaded, and here you can change the back face setting so that it looks that it has magenta color. So this is going to help you understand the orientation, and it can also help you easily visualize if there is a break in the geometry. So you can join everything back and it's gonna form a closed solid poly surface. Okay, awesome. So if you want, you can check this geometry. If you're lagging behind, you can join it, and let's pull it back by 200 units. And you can see how it looks under EMAP. Environment map. There we go. Is trimming the surface and creating a new surface going to mess up the UV when we are Sorry guys, I'm back. Apologies. I had a break in the internet. Yeah, Houston, we got a problem. I hope now everyone can hear me. I think everyone's able to hear me. Everything is back. Okay. Thanks for being patient. All right, so the next part. So a thing you might have observed as compared to Rhino with other CAD modeling softwares is that whenever you model in Rhino, everything looks like all the surfaces look really complex and they have so many lines going through them. However, if you model it in Fusion or Inventor or Creo or other CAD softwares, you see like really nice surfaces. Well, a reason for that is some of these softwares, they don't show the isocurve density. Okay, so in our case, we can turn off that option, right? And it can help you visualize the surface in a bit more simpler manner. Okay, if you don't want to see always the isocurves. So you can turn it off and we will go to the next step. All right, so let's look at the surface from the front. So in this part, we are going to create a curve, right? You can use a NURBS curve, degree 3. With Shift key, I'm just going to add a couple of control points, move it down. With Shift key, add a couple of more control points. Okay. And I'm going to do that one more time by copying and pasting it and maybe slightly modifying the position of these control points. Okay. So this is what I did here. Okay. So how can we put these curves on top of this surface? First thing, you need to explode the geometry so that you're just left with the surface. Okay. And then we can project the curve on top of the surface. Abito asks that he cannot select anything in the downloaded file. That's true because you might have in the layer tab the workflow Rhino layer or the construction layer, I think, locked. So when you have it locked, you can't select it. You need to unlock the layer. Okay. So yeah, we're going to project the curve from the front view. Project these two curves on this surface, right? And you can see we have projected the curve to these surface. And what is the next step? Let me just get back the curve with Control C, go back in timeline, and I'm going to paste it one more time. Okay. And what we can do is we can split this surface with these two curves. Okay, we split the surface with these two curves, right? So that you have this part as separate, this part as separate, and this part as separate. So what is the goal of splitting the surface? So we would like to add a feature in the front of the VR headset. Okay, so I'm just going to get rid of the central portion. And let's turn on the control point of the bottom surface. Okay, and you will see it is extended till the end, but you can ignore the top part. We will select this and this control point, and we will move it outwards. Okay, by how much? You can move it by, let's say, -5 units. Okay, so this is going to create like a slight dent outwards in the surface. You will be able to see it here. Correct? Now, how can we now connect these surface, like this hole that we have created, with the surface? Which command can we use for connecting this edge to this edge? Let's see who can give an answer for that in the chat. Daniela says loft. Loft will, yes, loft can create the surface from this edge to that edge, but the problem is it's going to create a straight section, and you will have this corner that is not going to be connected. Okay, so you won't be able to create a solid geometry after this. So what can we do? A lot of you are saying bridge. That bridge is probably in sub D, not in NURBS surface network. BDE concept, you have the right answer. It's sweep 2. Rishikesh, you as well. Faisal, you as well, thanks. So we are gonna do sweep 2. Okay, the only thing here to keep in mind is that we do have a rail. This is a rail. We do have another rail. This is the rail, but we need a cross section. And if you see, if I select here, it's going to select the entire edge. Okay, so we need to split the edge on those two sides. So there is a command called split edge. Okay, split edge for this corner, where we can split it on this point and on that point, and we can split it on this point and on that point. Okay, in the next step I have already done that, I think. Oh no, in the next step you will see that that is done. All right, so when we do sweep 2, you will select the rail. So don't take the curve, but take the surface edge, because we want to create some continuity between these two patches of surfaces. Because if you take the curve parameter, you won't be able to match the continuity. So let's take the edge as rail 1, this edge as rail 2. Okay, make sure not the curve, but the edge. Then the cross. Hello? Yeah, I think we are back. Sorry guys, I don't know why this is happening today only. Okay, so we are doing a sweep. Let me repeat. Sweep this edge, sweep this edge, cross section 1, cross section 2, press OK, and just make sure a couple of things. First, make sure to preserve first and last cross section, because we want the cross section to be the same as the edge, okay, so that we can close everything and create a watertight poly surface. Then we will match the edge continuity. You can test tangency, and you will see it slightly deforms the shape of the profile, and you can also convert it into curvature. Okay, and you will also see that my surface is trying to move always in this direction, the iso curves, but here in the center it would be better if it goes in this direction. So I can add a slash starting from here to the perpendicular there, right? And you can see now it creates a better flow of the iso curves. Press OK, and there we go. So now you can join everything back, Control J, and we should get a closed solid poly surface. You can also run emap to see the overall feature that we have added and how it blends perfectly to the rest of the shape. Okay. Now we are here already, and you can run the emap or zebra to see how does the surface look. I have also added a mesh head here that you can intersect with the poly surface. So you will use the mesh intersect command, not the normal intersect. Mesh intersect between this and the mesh, and you will get these outlines. What we are really interested in is just this one, okay, which is this outline, and you can use that outline to generate these cutting curves. Okay, so you will see here that using that curve, we are generating the surface that we will use to cut, and before cutting we are also shelling out the shape. So for shelling out, you can just explode it, copy the surface, undo the explode, paste the surface, and you can just extrude it inwards. You can scale it and then extrude it inwards. Okay, this will create, when you do a Boolean solid difference, hollow structure. Okay, so that is what we have done here. And once you have the hollow structure, you can use this curve that you have here to split this geometry with that plane. Okay, have that curve, just extrude it, and we will do Boolean split or Boolean difference. Okay, let me see if you have some questions. Sweep 1 for single rail, sweep 2 between two walls. Okay, my video is blurred. Try to increase the settings in the in your YouTube setting. I hope everyone is able to hear me and watch the video in good quality. All right, so once you have that, the next step is gonna be cutting the nose piece from here, and we will redo the Boolean difference, solid, Boolean split, and you can get rid of that part. So there we have it. So this is the outermost shell of our VR headset. Okay, so now we need to construct the headband for the VR headset. Headband we will do later. We have to first get the eyepiece, the internal part. So for that, you can start by taking one of the curves and creating a solid, and then splitting that solid by these different planes. Okay, so here you can see I'm splitting this shape with this surface to get rid of this. Okay, and I can also use the internal structure to get rid of this. But before we can join it first, yeah, that would be doing better with this. Okay, and you can get that internal structure. All right, so once you have done that, you will also remove the nose piece like last time. You will use the same profile, and there you have the internal piece. Okay, and then for the headband, we are going to create these curves and some profiles. So which command shall we use to create this surface? Let's see who responds to this question. We can do sweep 1. Sweep 1. So this is the rail, this is the cross-section profile. I will just move the seam line to the same curve to get a better result. Okay, there you go. You can also, when you run the sweep command, before running the command, you can also turn on the history mode. Okay, so on the bottom of the Rhino viewport, you will see there is an option called record history. Select the record history, turn on the sweep 1 command, select the rail, cross section, and perform the operation. So what is the difference here? As we recorded history for the sweep command, I can take the curve, and whenever I modify the curve, you can see I'm also modifying the sweep. Okay, so in this way you can control easily what should be the overall shape of the geometry. Okay, great. And these are a couple of easy operations. You can draw a rectangle with rounded edge, and for the top part, the same operation: sweep 1 rail, rail, profile, just align the seam to the profile, and there we go. Okay, and finally you integrate everything together. Okay, so this is the outer part, this is the internal part, and this is the headband. Okay, you can check it in rendered preview. How does it look? And yeah, I have added a couple of additional features after that. And lastly, to add the cut on the profile, you can pull the original curve to the surface, and you can run pipe, let's say 0.5 millimeters on the surface, and you can perform the Boolean operation to get this nice separation point on the front part. Okay. All right, so these are additional things that you can check in the Grasshopper file, how I have extracted these points to orient these shapes normal to these side surfaces. And finally, we get something that looks like this. Okay, now let's apply some textures to the bottom part of the VR headset. All right, any questions so far that you didn't understand in this step-by-step breakdown? So for those of you, if you have everything clear, let's move to Grasshopper. Why didn't you rebuild the curve first but rebuild the surface after the creation? Surface, so if you just rebuild the curve, it's just going to create a surface that is trimmed, right, in a planar geometry. So it's not going to have these additional internal subdivisions. It's just going to create a simple probably 2 by like degree 1 surface on UNV, but with the trimmed part. So the curve, the parameter curve, is not defining the internal UV parameters of the surface, and that is why we had to add those additional control points. Okay, so let's move to Grasshopper. So to turn on Grasshopper, let's click on this icon, or you can also run the Grasshopper command. And if you don't have any, like a lot of plugins, it should pop up right away. And we are going to work on our Grasshopper environment and see the results in real time in our Rhino environment. Okay, so what type of textures we're gonna apply? So I'm gonna explain two types of textures. So in the first one we will be applying some diamond textures, and in the other one we will be applying a pipe texture, but changing the thickness of the pipe along the surface. Someone is asking, can you show how to create those surface to be normal to the headset? Jimmy, you will find the Grasshopper file with the download section, and at the bottom part you will have the definition on how to do that. Avito asks, is my GH missing stuff? It opened instantaneously. No, it's not missing anything. It's just that I have a lot of additional plugins. Okay, that is why it takes a lot of time. Okay, so let's start. I'm gonna import the surface inside Grasshopper. So let's add a surface container by double clicking and creating this hexagonal black box that you see here for the surface to be imported. And to import geometry from Rhino into Grasshopper, we right click and we set one surface. Okay, and you will see that Grasshopper automatically minimizes, and it's asking us to select a surface in Rhino environment. Okay, so I'm going to select this surface first. All right, I can hide the original surface in Rhino. So we want to populate this surface with hexagonal panels. Okay, how can we do that? First, we need some containers where we can place those hexagonal panels or circular curves or anything that we want. So in order to place a geometry on a surface, you would create something called surface frames. Okay, so let's go to Surface, Utilities, Surface Frames. Okay, and this is going to create frames on your surface. Can you see that? You can change the number of counts in this direction, vertical direction, or the horizontal direction. Okay, let's add a panel to the output. You will see that as we are using a trimmed surface, there are a couple of data branches that are empty. So it's basically creating ghost paths for frames that doesn't exist. Okay, and the problem here is that you have certain lists with 6 frames, certain lists with 7 frames, and the frames vary along the list, the branches. Okay, and this is going to create a lot of problem for the next steps. So what I recommend you is that instead of using surface frames, we will be using another tool called a divide surface. So the divide surface is going to create the same number of points, but at the output, if you look, it is creating null values, okay, for all the places where there is trimmed surface, which means that it's giving us the data tree in equilibrium, it's structured. Just the thing is, it doesn't contain any geometry in that place. Okay, we don't really worry about that. We just worry about the place where the point is, but we really need this data structure. So that is why we are using divide surface. Okay, I hope you were able to follow along this far. So I'm going to set this to 33, this to 25. Okay, so the next step is going to be converting these points into frames, because that's how we can place a geometry on the frame. you can see we have the points, we have the normal direction. So in the vector tab, you can create a plane by using a point and a normal direction. Okay, so the planes are going to be here. So you will see it is creating a plane on each of the point, but all the planes are looking upwards. They are basically oriented to the XYZ coordinate of Rhino environment. But if I add the normal parameter to Z-axis, suddenly all the planes are now normal to the surface. Okay, so that is how we are going to create a lot of planes. Onlybeck asks, is this webinar going to be recorded? Yes, you can use the same YouTube link and watch it later on. So once you have the planes, if you get close to your surface, you might see these rectangular shapes. If you don't see it, or if it's really big or really small, you can change its parameter by going to display, preview plane size, and changing it to, let's say, 10 if you want it to be really big, or 1 if you wanted to if you want to make it small, or 0 if you don't want to see it. I don't recommend to hide it, just create a smaller frame. You will notice that some of the green lines or the red lines are not looking in the same direction. Okay, that means that our planes are rotated. Even though they are in the normal, oriented properly in the normal direction, they are rotated 90 degrees in different direction for different points. And that is going to create a problem. I mean, if we are going to create circles on those frames, then we don't need to worry about it, because circle is symmetrical, doesn't matter how you put it. But if you have something like a rectangle or some skewed rectangle, let's say, you connect a rectangular plane, you can see the problem here. Some of the rectangles are oriented correctly, some of them are not. Okay, so we need to align all our planes so that they all have a common axis. So there is a tool called align plane, and you just need to provide a guiding vector. So Z vector, we can set it to be common because we have always common Z axis for the entire planes. Okay, Z. And you will see that when you do that, all the planes are now looking in the same direction as well. So if you create a rectangle now on these planes, they all are looking in the same direction. Correct? All right. Let me get back. You can always hide the geometries that you are not using and just visualize the important geometries. What is the reason some frames are rotated? Most probably it's pulling the points to the surface, and when it does, it can flip the direction. Then the next step, so we are going to create rectangles on these planes. Okay, and let's create a rectangle of same size for X and for Y. So if you see, the size of the X rectangle is -1 to +1. It's a weird way of defining values in Grasshopper, but as you don't have access to the mouse, you have to find creative ways to define these values. Okay, that is why we will be using a domain. Okay, construct domain. And we can tell a minimum and a maximum value for the rectangle. So let's say the minimum and maximum value is 2.5 or 2.0. So we can set it to this, and the symmetrical part with a negative node. Okay, and you will see now the rectangle is symmetrical in the vertical direction, and you can repeat the same for the horizontal direction. Okay, or if you want this to be a same size rectangle or a square, you can use the same domain for both. Okay, something like that. Any questions? Any reason for this variable alignment? Variable alignment, I didn't get that question. So once we have the rectangles, we need to kind of filter these rectangles so that we can have a hexagonal grid of rectangles. What I mean with that is, let's say I want the first rectangle and I don't want the second rectangle. Third I want, fourth I don't want, and so on. In the next list of rectangles, I want the first one but not the second one, so it's inverted. Okay, so one row it's odd, even, odd, even, odd. In the other row it's even, odd, even, odd, even, odd. Okay, so we need to filter out these rectangles in that way so that we can have a staggered frame distribution. So for that, let me just disconnect this. We will get back to it later on. For those of you who don't know to disconnect, you can right click, disconnect the frame, or you can use and hold Control key and disconnect it. Okay, so we have these frames and we want to filter it. So I'm going to do some dispatch operation, dispatch, where we're going to filter the frames in list A and list B. So let's add a plane container. So you can see these are all the plane A and plane B. So I'm able to filter the planes in these two lists. So let's just focus on plane A. Okay. Once we have this, I can filter it one more time, but rather than filtering it vertically, I can filter it horizontally. So there is an operation where we rotate the list 90 degrees using flip matrix. Okay, we basically had, this is some advanced operations, so don't worry if you're starting with Grasshopper. So earlier we had, let's see, 34 branches with 13 points in each. After that we will have 13 branches with 34 points in it. So rather than reading the list like this, we are reading the list from left to right. Okay, and we can do one more dispatch to filter the alternatives. And finally you connect a plane here, plane container, and there you go. So this is our first set of planes, and you can basically copy this entire pattern for the bottom list, and rather than taking the planes from list A, you take it from list B. And now you can see we have this alternate distribution of frames. Okay, and finally you can merge it as a single list, and we can flatten it to get a single data tree, data branch. Okay, and here we can create the rectangles. Okay, there we go. Now we can also rotate the rectangles by 45 degrees. Okay, so we are rotating the rectangles. The plane is going to be the same and the angle is 45 degrees. Okay, you will see that it is working, but when you change it, it's acting weird. That's because the angle by default in Grasshopper is given in radians. So if you want to provide degrees, you have to right click and set the degree parameter here. Okay, and there we go. We have now created the rotated rectangle. And finally, what I'll do is I will scale the rectangles, but differently in different axes. So rectangles, plane is going to be the same for all of the operations. And here we can define how I would like to scale it. So if you want to stretch it in the x-axis, you can set it to 2. Okay, so the plane is rotated. For it, it might be y-axis locally. Yeah. Again, you can see we have created these diamond panels. Okay. And finally, we can extrude these frames in the same direction as the frame. Okay, so you can connect a vector container to convert the frames into direction. There you go. Okay, and finally you can cap it to convert this into a solid geometry. And you can do Boolean operations now with the these poly surfaces. Okay, so you can right click, bake, and group the objects, right? And you can do Boolean operation with these diamond frames. Okay. If you look at the file that I have shared with you guys, so let me just open this file, drag and drop. You will see what I have done. Okay, so I have first of all added some fillet to the rectangles, rotated it like what we have done, scaled it, and extruded it. To control the direction or the depth of extrusion, I am basically pulling all of these frames to the curve and calculating the distance and using the distance as a parameter to control the depth. So the frames that are closer to the boundary are not extruded farther, but the ones that are farther away from the boundary are extruded a bit deeper. Okay, and that is how I have created that pattern. Were you able to open the Grasshopper file that I have shared with you guys? Everyone, hello. The chat looks lonely. Any questions? Why no make the Boolean in Grasshopper? Because it's going to take you a long time. In Rhino, the Boolean operation can take the advantage of multiple cores, but in Grasshopper it doesn't. There is a plugin called Sasquatch, I think it's called. Let me see. Yeah, this one. And there is this tool called Fast Solid Difference. Okay, For a couple of components in Grasshopper, when you see these two dots, that means it has parallel computing. It can take advantage of multiple cores as compared to the Boolean difference or solid difference that we have by default in Rhino. This cannot take advantage of parallel computing, so it's going to take a lot longer. Okay, if you have this plugin Sasquatch, you can use the Boolean difference in Grasshopper. Okay. ¿Cómo encuentras el comando idioma para cada operación? Rafa asks, how do you find correct tools for operations? It's just experience. The more you use, the more tools and plugins you will know, and the better you will be able to tackle the problem. All right, the other texture variation is also really simple. You basically create contours, right? You divide the geometry by parallel lines, and you create pipes on those lines. Okay, you can use, like we have seen, how you can create pipe back here, over here, right? So you create the same type of pipes. Just the difference is you can use a tool called variable pipe, where you can tell from which part to which part what thickness can the pipe have. Okay, so this is how we can control the thickness, right? And you can change these variables. Okay, so I have split it into lists because the top ones were really small curves and it was not looking great, so I split it into two parts so that the bottom ones have some distance and top ones similar distance. And finally you can bake it as well, and then do the Boolean difference. So I'm slightly gonna separate it from the original geometry and do the Boolean difference here. Okay, and there you go. Boolean difference with these. One is not better than the other, it's just that one is faster than the other. Okay. By the way, to learn Rhino from zero, best way to learn Rhino and GH from zero. Yeah, I mean, this is not something that you do from zero, but I think when you practice more and more, like with tutorials, and at the end I'll also share some of the courses we have, you can learn it from there. So once you have finished applying the texture, now it's time to render the headset. Okay. Any question? Can you write down the name of the plugin? Yeah, sure. It's Sasquatch. I think ATCH. All right. Couple of things to keep in mind. Just you can define the layers based upon the materials. In this particular case, because we are not going to do animation, and whatever material you want to put, you put that in a single layer, so that it's easy in Keyshot to apply the materials. And the good thing about Keyshot is that it can import directly files from Rhino. Okay, so you can save your Rhino file as it is, .3dm and import it in Keyshot directly. So you don't need to export it as OBJ or STL or IGES. Okay, so let's move to Keyshot. Most of the plugins are free. You will find a zip folder. You can right click and extract into a single folder all the files. And I have added 3 different render files. So the one that we are going to open is the first one. Okay, let me open Keyshot, file, open the first one. Okay, it's going to ask where it would like to extract all the resources. You can just extract it to the resource folder, and there we go. So I'm just going to give you 1 more minute so that you can catch up till this part. You will find in the download folder there is a zip file for Keyshot. Inside you will have 3 different files, and we will use the first file and import it in Keyshot. Okay, so I have added some materials already. You don't need to do that. So we will see 2 things. First thing first, if you go to our web page, in the resource tab, you can find we have a post about creating studios in Keyshot that can improve the quality of the render drastically. Okay, so first we are gonna follow this tutorial where you basically create a custom HDRI and create your own lights to create the contrastic effect that you see here, right? Rather than using the startup HDRI. So for that, let's go to environment. You can see this is the HDRI that we are using at the moment, correct? So let's create a new blank environment. And let's go to the HDRI editor setting tab, and there is a background color which is grayish, so you can set it to any other color, but in our case we're gonna set it to black. So the entire HDRI is totally black, and we will start to add lights. So when you click on the add pin tool here, you will see that a light has been added in your HDRI. And whenever you add a light, you will see this tool turn on automatically, which is basically for clicking anywhere to position the light normal to the place where you have clicked. Okay. So we will create something like a 3-point light studio, but you can add as many as you want. So once you are done with the positioning of the light, let's add a new light. Something around here. Let's add more lights, maybe something to light up the bottom part. Some more lights. Okay, and you will see that in the background you are seeing the HDRI lights. Prajwal is asking, yes, you can download the files whenever you want. Whenever you register, you can download the file. At the background, you are going to see whatever is happening in your HDRI editor. So if you don't want to see what's happening in the HDRI as your background, you can go to the normal setting tab and change the background from lighting environment to color. Okay, and you can set a fixed color for the background. Okay, let's go back to HDRI and keep on adding more lights. Okay, depending upon your requirement, you can add as many lights as you want. You can also change the brightness of the light source. and size of the light source. Okay. So you will see that I have added a custom environment, so you can click here and this is gonna show you the settings that I had, but if you don't like, you can use your own settings. And the next part that we're going to do here is about adding a logo embossed in this part of the geometry. So when you click on this geometry and you see the material type, let's double click it, open the material graph of that geometry. Okay, double click material graph, and you will see that I have added this logo. You can just disconnect it, this logo, and we would use that logo to create like a 3D embossed effect on this part of the geometry. Daniela is asking, generally how many lights do you introduce in a studio environment? Depending upon what's the requirement, but you can add maybe 3 primaries and then you can add a couple of lights that are subtle to make sure that none of the part of your geometry is like really dark or really bright. Okay. Let's get back to the material graph. You can also move these tabs so that you can see your environment properly. You can even close this tab and move this beyond that part. Okay, so first things first, you need to correct the mapping of this texture. So there is a tool called Preview Color. Okay, I'm going to select the node and click here, and you will see that this tool is going to position the logo on the geometry the way it is mapped by default. And what we're going to do is we're going to control the mapping of the texture. So first things first, I'm going to convert this to a planar mapping. Okay, and then click on Move Texture command. It's going to pop up this window, and you can basically click anywhere on the front part and it will orient itself automatically normal to the place where you are clicking. Once you're happy, you can press OK. And you can see we have the logo mapped in that center of the geometry. You can also change the size by going to Scene Units. You can reduce the size of the logo. And you can also see that the logo is automatically repeating in horizontal and vertical manner. So you can turn off repeat horizontally, and you can turn off repeat vertically. So you just have a single logo, and you can move it if you want, if you don't like the position, something like that. Okay, you can go out of the mode. Sorry. Now, which command shall we use in order to add the 3D effect in this part using this texture? You can try with bump. You might get subtle effect. Let me exaggerate the values. It doesn't show up that much, so maybe this is not going to be useful. The thing is, the bump or the displacement effect happens in black and white values. So we need to convert this image into black and white. So to do that, you can add a utility node called color adjust. You add the color. Let's turn on the custom preview for the color adjust node, and we can then make the value really big. Reduce the saturation to 0 to make it black and white, and change the value to a high number so that the entire text becomes white in color. Maybe now it works. Subtly I can see it. There might be one more reason that we don't see it, that I have added a rounded corner effect in Keyshot. Alright, so in order to create the 3D effect, we need to add a displacement node. You need to connect it here, and that part goes to the geometry operation. You will see that this button pops up. That's because whenever you add a geometry node, you need to recalculate everything. So when I press that, you can see the logo is being implanted, but the height is a lot. Okay. So we need to double click the displacement node and change the height. Let's set it to 1. Okay, now it's a bit better, right? But you will see that the quality of the displacement is not good. And that is because you can, if you disconnect this, you will see there is this mesh density that is being controlled by the triangle size parameter. Okay, which means that we are creating really big triangles to define the text. So if you want to define better the details, your triangle size needs to be smaller. So you can try 0.1. Let's recalculate the geometry nodes. As you can see, it's taking even longer, but you see that the quality of the displacement improved by a lot. Okay, and if you want the effect inwards, you can set the value to negative something. Let's say negative 0.5. Let's recalculate. And there you go. Okay, if you want even better quality, you can keep decreasing the triangle size. Okay, and it will create better outline of the logo. Of course, you can do this in Rhino as well, but if you want to apply or emboss some kind of logo, you can do this in Keyshot as well. Okay, any questions? Anyone, any question? Okay, so you can also kind of fillet the corners if you forgot to do this in Rhino in Keyshot by going to this option called rounded edges, and you can add slight roundness to the corners. It's gonna take a while because you have added a displacement node. As you can see, it's taking a long time, but it can fillet slightly the corners. Paulo, yes, the webinar is recorded. You will receive an email with the recorded link. Ashmak is asking, can we have a tetrahedral mesh rather than a triangular mesh? I think triangular mesh is by default what Keyshot creates, and we can't control that. You can control the mesh density by right-clicking and reteslating. Okay, you can control the amount of polygons by increasing the mesh quality. Okay, or reducing it if you want simpler geometry. Okay, so you can control that, as you can see here. And this is sometimes you might also encounter that your geometry is looking really low poly. If you have made it using NURBS workflow, you can right click and retessellate it. Okay, great. So this is gonna be an overall workflow for this, from Rhino to Grasshopper to Keyshot. Okay, have a couple of more things. You can check the folder, and I have added 2 more variations. I have a copy of the same texture, that's why it's giving me an error. So this is another variation where you can use the real cloth node or some texture for cloth, and another variation is the metallic. Let's see, for metallic parts. Okay, so you can switch it, you can create your own patterns and textures, and you can use these HDRIs and scenes to render your own headset or any other geometry. All right, any more questions? Melissa asks, she tried to rebuild the surface but it didn't do anything. Did you confirm it by turning on the control points? So if you go back to the first surface, when you rebuild it, turn on the control points, and do you see these many control points, or you just see something like this? Sorry, like this. Omkar, you can, what render settings do I use in what context? Are you talking about for rendering output? When you render, there is an option for quality, and I generally render in maximum samples. And how do you know how many samples you need to render it? You select your camera, and there is a tool called heads-up display that is going to display how many samples have been calculated. Okay, and you need to provide this value over here. So the longer you wait, the better the render gets, and you need to provide the same number of amount, or maybe slightly a bit higher than the total number of samples that you needed for creating a good render quality. So I will try to focus on a part where Keyshot is struggling to create a good noise-free render, like this part, and I will wait and see how many samples do I need to create a good quality render. So maybe 100. I can still see some graininess. I can probably go till 150. Okay, so the more samples you add, the longer it's gonna take. So be careful with how much you're gonna provide for the sample amount. So let's say 200, and that is gonna be the render setting for this render. Can you mirror the logos in Keyshot? I think you can just copy the part and then rotate it, but in this case it's not symmetrical. You have it in the other side, but the problem is you have to remap it one more time from this side, because if you use the same mirror it's going to be inverted. Okay, so you have to flip the image, or you can flip the image also in the settings of the texture. How did you get that info? This one is called heads-up display, view heads-up display, or you can press H. All right. So before we close, let me just go through some things quickly. I also printed some of the designs. So I'm using an SLA printer. I'm sorry, it's going to be a bit difficult to see on the small cameras, but turns out pretty nice. And I also have some other texture prints from other workshops. So if you're interested in getting a 3D printer, you can get a resin printer. I'm using a Lego Mars. And apart from that, if you are interested in learning more about these softwares, you can check our webpage. Okay, of course you can check first the resource tab, where we also have the previous webinars where we created this one in the same workflow, as well as the trimmer and some other things. We will keep adding more stuff. And you can also check the courses that we offer. So we have the Grasshopper course, where the most important part is learning about, how Grasshopper works, data tree, flatten, graft, list hierarchy, matching data. Then we will advance into more concepts like point attractor, image sampler, parametric design, and then mesh and sub-D workflow. Okay. You need to understand these courses are live courses, so I'm gonna be there during the weekend and teaching you these concepts. So if you have any question, you can ask me in real time, and I can help you in real time. I can control your computer and assist you through the concepts and exercises. We also have an advanced course for Grasshopper, where it's specifically designed to create different types of textures by using different techniques, be it Grasshopper or Rhino. Okay, so you will learn how to create Boolean textures, single surface textures, deformation techniques, and some other texture that you can do with tweening curves in Grasshopper. Okay, and we also have Rhino course. So if you are new to NURBS modeling, you want to improve your surface, hard surface modeling or surface modeling, patch and match, continuity, sub-D modeling, you can check out our Rhino course. And finally, we have the Keyshot course. You can check the video where we explain what are the concepts that we will go through, so you can have a good look at the modules. Okay, and you can check about our upcoming classes in the calendar tab. Okay, and here we have the next dates for February. So we have Saturday, Sunday, Keyshot, advanced texture, Grasshopper, and also for March. But in any case, if you have any questions, you can always register and we will get back to you with more information. All right, so last year was great. We were able to provide training to designers, students, studios, and meet really creative people all around the globe. And we were around more than 300 students, and we provided more than, I think, 45 classes. And we really appreciate all of you for making us part of your professional endeavor. And let us know, yeah, if you have any questions with about whatever we do, or any courses, or just these webinars. You can contact us on LinkedIn, Instagram, on our webpage, or the email. Okay. In case you make any of these geometries that we did in webinar, or you create your own VR headset or any other textures or patterns, feel free to share it with us on our social media, and we will repost it, of course. And we'll also publish it in our portfolio page. You can check that out as well, from works from past students. And yeah, that's gonna be it. Any additional questions before we close in? To do double curvature on previously perforated sheet of metal. That advanced course is useful if I have zero experience on Grasshopper. If you want to make the most out of the advanced workshop, we recommend you to have some knowledge in Grasshopper, and that is why we have the Grasshopper Masterclass, where you can just enter without any knowledge of Rhino or Grasshopper, and when you end, you will be able to download files, understand what is happening, understand to read the Grasshopper script, and start to create your own scripts. Then you have thank you, Carlos, for the feedback. Paulo, please, Aman, which software is the best to do double curvature on a previously perforated sheet of metal? To simulate a real physical deformation of an already drilled sheet. I'm unable to answer that. If I find something, I'll definitely write to you. Write back to you. Thank you, Carlos, Daniela, David, thanks for joining, and thank you so much. Easy to follow. Yeah, I mean, we have a lot of things to pack. That is why we have prepared the files in that way, and it's mainly to give you guys a rough idea on how to do these workflows from Rhino to Grasshopper to Keyshot. Jairo, thanks. Diego, thank you. Muchas gracias. Rishikesh, thank you. Noah, thanks a lot. What software is better to do? Blah, blah, blah. Okay, I will write back to you, Paulo. Elijah, thanks, man. For you, it has been a really long day. Rene, Avito, yeah. The course are, yes, one-on-one. We will have a group of 4 or 5 people join in with Zoom, and we will follow the course through. And whenever you have any question, you can ask me. I'll help you if you have any question, if you have any doubts. Perfect. So really appreciate it. Thanks for joining. Hope you have a great weekend, and see you guys in the next webinar. All right. Bye-bye, guys. Take care.